and it's a few minutes past class, it's because I'm getting things started up. Just so you know, it's not because we're not having class, it's because it takes a few minutes to get going here. Let me minimize this and get that out of the way. Oh, let me make sure. Can you hear me at home?
Yes.
Okay. All right, so we are recording and ready to roll. Let me go ahead and do OneNote. And just like these, I don't know if you've been into Blackboard since last class, but if you look under lessons, this is now there in there. So at the, every day, every day I post the notes. And they're labeled according to today. I'll usually change these. I'll put more descriptions in them when we come around when we're reviewing. Now, the one thing, let me come back to this. Oh, wait, I don't know if I did. Video's working. Yeah, that's all working. Good. All right. So anyways, here's the way it normally goes. I start up these things. So I've got the recording going on. Do you guys have any questions, any homework questions that you'd like me to work? You did. If you got them, no big deal. I'll just go into lecture then. And then usually what I do while I'm in class is I always reference the book a lot. We don't do anything that's not in that book, for example.
So you said, look, since you have our home, how long is it going to be? Tablet, or do we have to go to the library to?
Nope, it's on the tablet.
You don't have to print it.
Nope.
Okay.
It is connected to the internet. So yes, you don't have to do no printing, nothing. All right, let me go and see if I can remember my login name for this thing. I remember what it was. I don't remember what it was now that I think about it. Well, we'll do another one then. I'll go in your way. Blackboard. You all been through there then? You've gotten to the Blackboard way?
Yes.
Okay, good. They've switched things a little bit this semester. That's why I got a little bit nervous. So let's pop into Alex. Back in here again for a second time. I'll pull up the syllabus while we're here. I've fixed it up now. It should be up to date. So if you look on the last page of the syllabus, it has our schedule that we're going to do. So today I plan on doing 1.6 and 1.7. You can see, and it goes throughout the rest of the semester. The things in yellow, of course, are the important dates. You don't have to write it. All this is in Blackboard. Now let's see if it actually got into Alex. Yes. It says launching a new window. Did it actually launch said window?
So I have a question. So is 1, 1, 2, 1, 6, and 1, 7 due Thursday?
No, they would not. Let me come back to that then. Come back here. Whenever I cover material, like we did 1.2 on last class, that's going to be due on a week later. So the only thing that would be due on this Thursday would be section 1.2.
Okay. Okay.
And so every time I do something in class, you get a week to do it. So that gives you one class period to ask about it. Okay?
Okay.
Let's see here. I don't know why this is not launching, Alex.
I always have to hit.
What'd you say?
You know, when you came down to the,
Let's try it again, see what happens. You say it doesn't launch very well?
if you click on new.
Oh, I see. Okay, so that's clickable things. Got you. All right. So, and I'll pretty much, I mean, I'm not gonna go outside of the book, really. Besides making up my own examples every so often, I'm just gonna be going, what you're going to be learning about in chapter 1 is you're going to find that you remember some of it, but you don't remember some of it. It's gonna be, chapter 1 is meant to be a review. It's not meant to reteach you the material, although we'll certainly do enough examples that will definitely remind you. So when you look at the textbook, this is the book right here that I'm looking at. Did you see what I clicked to get here?
Mhm.
Did you guys see what I clicked to get here? All right, let's go back. This is all, oh, it does the whole page, doesn't it? How do you go back in one of these things?
Oh, you gotta click the arrow on
This
top.
guy right here?
Yep.
No. I want to go back to the class itself. There we are. Gotcha.
You gotta exit out of it. Oh, yeah.
This is the guy you click. That's the actual textbook there. So, and it's the same as the printed one.
And it's through Alex.
You go, right, exactly. You go, you don't need to do anything except go to Blackboard, and that's, your whole world is in there. That's all that matters. But now I gotta move these things around so I can find, where did I put the book? I don't need this page anymore. All right, so I'll cancel that. I'll keep this up. Let's go to the book. All right, so the book just kind of opens on top of everything, but I want to go, we're doing 1.6 and 1.7. So these are all those rules that you would have had. The whole thing, the first test is going to be the orders of operations and the PEMDAS that we were talking about last time. We're going to just be doing it more and more in higher levels as you go. It's going to just basically get more complicated. So let me pop down. Here's a typical example. I'll come to the homework assignments and I'll sort of explain them as we go along. But when you do this, the odd ones have this little answer there. See it? If you hit it, it'll list the answer. You with me? Now that's why I typically do the even ones in class. All right. I have to grab it on my own. All right, let's start with, I want to give you a sort of a very simplified, a simple version of what 2 times 3. When I was in school, my teacher told me that multiplication was a fast way of addition. You taught something like that. So when you do 2 times 3, we know it's 6. You were taught. That's why you learned the multiplication tables, so that you would be able to do these most problems that you come across without having to do excessive computations. So this one, if I write this, does this make sense to you? 2 times 3, right, exactly. What we're going to look at is something like this then. What does that going to be? -6? It will be -6. That's true. We want to develop these things organically though. So let's first start with addition.
I want to make this a little bit thicker and I think I'm done with it. It's fine. That's the one I think I want.
You're assumed to already be able to add positive numbers together. we don't teach that. But now what you might have a complication with is the following. What is, say if I add 3 plus -1, what does it mean to add a negative number to a positive number? Now, many times it's useful to use a number line for these problems to sort of explain geometrically what it looks like. And it's the hope that these, number lines will be something you remember, and it'll be something, not a horrible memory from childhood. You would like, oh, yeah. I remember these things. So on these number lines, typically what you might do is you might put, the numbers on them. And then what if we go over here too, we can put numbers in the negative direction. Now, negative numbers are a fact of life, so it's not like we don't have to deal with them ever. You may see a negative number when your bank may become negative, your bank account might become negative one day. But more importantly for us, on a regular basis, we definitely saw negative temperatures last week. So the way we do this is the following. I'm going to start here at 3, so I'll put a dot with a 3 in there. Now I want to add to it -1. Now typically, when you add two numbers, like if I were doing 3 plus regular 1, then what I would do is I would move to the right 1 space. I get 4. But if I want to, what do you think it should be to add a -1? What should it be? If I go to the right when I add a positive, what do you think the negative should be? It'll go to the left. And right, we'll have the effect of subtracting. So what I'm going to do here is I'm going to add -1 unit to the left. And we arrive at 2. Okay. Of course, this is the same answer. You know that. Do you know that when you multiply or add, you can add in any order that you want? I can swap the orders. So you know this one here. This rule of mathematics says that you can do this. You know what that's called?
Associate.
Not quite. But you're in the right ballpark. Commutative properties. Commutative. They come. A couple things I want to show you too. Notice that the -1 has parentheses around it in the first instance, but the second instance, I don't put them. It wouldn't have been wrong to put parentheses in the second instance, but that's written by authors typically will write the second way without a problem. They'll always write this way. The reason they do that is while these are parentheses, they don't really act like parentheses. They're more like a placeholding spot for the negative portion. You understand? So the first part of anything is parentheses. Remember the PEMDAS? That doesn't quite count as a parenthesis, so it doesn't take place in the PEMDAS world. I'll remind you of it about 100 times this semester, but for right now, that'll be enough. That's what I'm looking for. Right? Now then, what would happen if you do this? This time it'll be -1, but let's use the number line.
And the number line, you only need to draw as much of it as that's useful to you. You don't have to reproduce the whole thing every time. That should be enough for what I need to do. All right, so accordingly, where should I start? Where should I put my initial dot? 3, at 3. I'll start at 3, put a dot here. Now, which way should I proceed? Left or right? Left. To the left, how many places? 4. 4 places, that's right. So I'm gonna go from this spot and I'm gonna go 4 places to the left. And then this is my, I don't know how, what I'm gonna put here, but I'll put my ending dot here. So what's the answer to this one then? -1. -1. So you can see that if I take a positive number, I can move to the left a little bit and still stay positive like in the first example. Or I can overwhelm the positive aspect, the negative is too much, and end up in the negative territory. Of course, with commutativity, this is the same answer. -4 plus 3 also equals -1. So we can do this then. What's going to happen if we get, then what about something like this? You know it's going to end up being -7, I heard you say. However, let's think about it in terms of this moving to the left and to the right. Where would I start my number line at? -4, -3. Let me start at my -4. Look where I'm going to start. I'm just thinking that the one on the left to start with. You can choose -3 to start with. That means then I'm going to put my 0 here so I have space for all my negative numbers. I know I'm going to use -7, so I at least have that negative. All right, so we're going to start at -4. I'll put my dot here. From -4, I'm going to go 3 places to the left. And where do I end up at? 7. That's too easy in a row. So you can see now, I bet you can make a general rule of things. If I have a positive number and I add another positive number to it, what kind of a number am I going to have? Positive. Absolutely positive. Because just look at it this way. If the positive number, you start on the right, already to the right of 0, if you're a positive number, you're going to keep going to the right. So be even more positive than either of the two numbers that made it up. Now, I bet you could answer this one also. What's going to be a negative plus a negative? Negative, because you're going to start to the left of 0 and you're going to go left. That's easy. So we've got these two easy cases. Now, we have this one. What about this? It could go either way. It could go either way. It depends on who's the more powerful of the two numbers. In the one example here, in this last example, the negative number overwhelmed the positive one, didn't it? But the one before it, positive overwhelmed the negative. So we can't say absolutely for sure what's going to put here. So the best I can put here is it depends. It depends on whichever one is the more dominant number. That's a word I'm going to make, I'm using, although if you look it up in the book, the word doesn't appear. I made it up for this purpose, because I think it gives a good idea of what I'm talking about. What I'm telling you is this. Here, -4 was the dominant number because it overwhelmed. Up here, 3 is the dominant number because it overwhelmed. You understand? Yes. Your book will go through a lot of words to give you that same feeling I just gave you. They'll use absolute values and all this other stuff. I don't want to bother with that. I think it's a more intuitive an idea that you can use instead of the more complicated. It doesn't, either way doesn't matter in the end, because in about 5 weeks, these rules will be, you'll know these anyways. Whatever we use to learn them. All right, so we have, that's the best I can do there. Now we're going to start looking at the multiplication. Now I can go and do what I was talking about. The same thing is true when I do multiplication. You may see something as simple as this: 3 parentheses -2. That means 3 times -2. Whenever you write two quantities right directly next to each other with nothing in between, the assumption is it's multiplication. But let me go a little further. According to the rule for multiplication, I can take, this is a shorthand for addition. So this could be -2 plus -2 plus -2. Now let's use what we just did. What's going to be -2 plus the -2? -4. -4. Negative plus the negative. 4. So just this part here. This, I'm doing PEMDAS. But there's only one thing to do. Now, -6. -6. Starting at -4, go to the left 2 places and you'll arrive to -6. So back, can you tell me what this is going to eat? Can I say this for sure? That this actually has an answer? Negative. Absolutely negative. Because when you take the positive, all you're going to do is like this. My +3 just meant that the negative number showed up 3 times. You understand? So whatever this number is that negative, this negative number here is going to show up that number of times. You get negative plus a negative plus a negative. So if you start it to the left and you keep going to the left, you're going to keep going farther to the left. So that one's easy. The one you knew before you walked into this class was that a positive times a positive is positive. One that we haven't covered yet is the following. Positive. It will have to be positive, yes, is that correct? It's at this stage, I usually like to come up with an example to show it, but for this particular one, I've not been able to come up with a really simple example to sort of explain it. I had to do something, what do I say? I had to write things on the board that when I looked at the students while I was explaining, it was clear that they had no answer. But just memorize this. So we have all the rules for doing some of the problems that we're going to do.
Let's go and grab. Now I can grab some homework problems to do. So let's see if you can do. Okay, so first, tell me, is this going to be positive or negative?
Negative.
Negative. Now, we need to be able to come up with rules that will help us use this. I can't have you doing like -9 plus -9 plus -9 plus -9. No, we need faster, the ability to do it faster than just writing that out over and over again like I would. So what we do then, you know it's going to be negative. We already know that. So let's go and put that part of it down.
Now, how do you come up with the part that comes after the negative? Well, this is where you use your rules that you are supposed to have memorized years ago. What's 4 times 9? Right, so the answer is negative 36. Now, if you take 9 plus 9 plus 9 plus 9, 9 plus 9 is 18, 27, 36. Just imagine doing the negative fraction. Negative 9 plus negative 9 is negative 18. 7, 36. Doing these one at a time, I'm gonna grab a collection of problems, I think. I'll do the even ones and leave the odd ones to you. Should you want, I mean, plus you have homework anyways. But let's go ahead. Let's do these. Grab these guys. Like, why are you doing that? I'll show you in a minute why I'm doing that. If I pick them big, they're easier. Are you serious? I didn't even put that little dot there. If you make them bigger to begin with, it's easier to increase their size later on. Yeah, how good they look. All right, let's start with the first one, number 6, positive or negative? Positive. Positive. So let's at least get all those in place. So I'm gonna have, this will be positive, so I'm not gonna write anything. What about this next one, positive or negative? Positive. So -4 times 3 will be negative, won't it?
12 times negative 7.
Times times negative, then 4 will be what?
Positive.
Positive. So I'm not gonna write anything after that equals. These are both positive answers. Now the last one, what about number 8, positive or negative? Negative, because 5 times -1 would be 5, right? 5 times -1 would be 5, and then once you take 5 times -11, you'll end up with -55. Now, if you want to do these problems, I don't care if you do them by hand or use your calculator, it's fine with me. 23 times 48, I don't require you to do it by hand, although you can if you like to practice that. But I'll just use a calculator myself. So you can just in your calculator type in 23 times 48. It's like, it's what they call the negatives cancel. This is what they say. The negatives cancel. That's a phrase that you'll hear often. They undo each other, really. I mean, that should make sense, shouldn't it? I want to give you a sense of what being negative means. Negative means to go in the opposite way. So start with something like this. Here I'm at, I'm standing here. Now, when I take a number and you multiply it by a negative number, what it does is it goes over to the other side of the number line, on the other side of 0. Now, if I come over to the other side of 0 and I multiply this guy by a negative number, it becomes positive. It's sent it to the other side. Okay, so we can do this. Look at number 5, -5. -5 is on the left. Times by -1, now we're on the right. Times by -11, we're back to the left. You get it? Left, right, left. Here, left. When you do that, it doesn't change the sign, so I can't use that trick there. But for this, then you can just go in order. What's -4 times 3?
-12.
-12. And now what's -12 times -7? Positive 84, because the negatives cancel out. We don't typically put a plus sign, but it's not wrong to put a plus sign, it's just we don't typically put it. You won't see it listed among the answers. For the last one, we could have done this one by in our heads, I think. -5 times -1 gives us 5. And then what's 5 times -11?
5, -15.
-5. That's why you got the negative. Any questions? About this?
Fractions work the same way, nothing changes. Let me see if I can pull up. I think the next, the one next was there were some fraction ones here. So let me go and pull 9 and 10. Oh, might as well, decimals work the same way.
So before I actually do anything, let me get the signs on them. The sign, I mean positive or negative. Let's see if we can get positive or negative on each one of these before actually doing the problem. So on this one, can you tell me if that's positive or negative?
Negative.
Negative, because it's a positive number times a negative number. For the next one, positive or negative?
Positive.
Positive, so I'm not gonna write anything. The one after that, positive or negative?
Positive.
Positive, I'm not gonna write anything, and then the last one. Negative, negative times a positive and negative. So in a way, I don't know if it'll help you, but if their signs are mixed, if one's positive and one's negative, when you multiply them, you'll get a negative number. And now let's go ahead. This is where I'm gonna try to remind you of how you multiply. Let me come, now that I know that's negative, I can ignore the negative numbers. I can ignore the negative numbers and just work the problem. Now, you'll remember when you multiply fractions, how do you remember the rule for multiplying fractions? How do they work?
You reduce.
Well, that's true, but the rule for fractions, if I have an A over B times a C over D, then I can multiply across. That's what I've heard people say. And you can do that here too. You multiply, what's 4 times 11? 44. And what's 33 times 10? 330. You could do that. You write 44 over 330. But you might remember, you were taught to simplify fractions before you multiply them. If you look, see that 4 up there? 4, I can cancel with that 10 because 2 goes into both 4 and 10. So what I'm saying is this 4 right here, if I divide that 4 by 2, I'll get 2. If I divide this 10 by 2, I will get 5. Do you remember this? This is something you can multiply them and simplify, or you can simplify them before multiplying, it'll make it simpler. The whole point of simplifying is to make life simpler. With that said, if you see another cancellation or simplifying I can do right now.
11, 3.
11 and 33. So if I divide 11 by 11, I get 1. And if I divide 33 by 11, I get 3. So after all that, let me rewrite it so we can see what I have. 2 over 3 times 1 over 5. This will end up being a simplified, the answer will be simplified. Now, in math courses, you probably know that you're going to be asked to simplify everything anyways. So since you're going to be asked to do it, it's easier to do it before you multiply it than after you multiply it. So here we get 2 times 1 divided by 3 times 5. So that's 2 over 15. Oh, you're right. I forgot that when we were putting into it. That's why this saves me so often. Because when I go to put my answer on, oh, thank God, because depending on how long the problem is, you can forget what you were even doing. Let me get that circle out of there. Now it's circle line. All right, the next one, we know it's a positive number. Let's do some simplifying beforehand. So look at this next one, number 10. You tell me what I can do. Tell me where I can simplify.
The 14 and 28.
The 14 and the 28. In fact, 14 goes into 28, doesn't it?
Yes, twice.
If I cancel 14 into 14, then I'll have a 2 down here.
Here's a thing.
Next, again, simplifying that can happen.
The 3 into 15 and 3 into
3 goes into 15 and 27, absolutely right. So 3 goes into 15 how many times? 5. 3 goes into 27. Now the negatives cancel, so here's what I have after my simplify. I'm not always going to write all this detail, but I am going to do it in the first, for the first little bit, so we can get comfortable with it. And now I can make the rule. So what's this going to end up being when we're done? Is equal
518.
518. Now, if you were to have multiplied those two fractions together without simplifying first, this is what you would have had. Now, if I gave you a fraction like that, I said simplify it, what would you do first? No, you don't, no, you're not adding fractions. That's the only time you comment on there is when you add fractions. And we're definitely not adding here.
I mean, if you find a number that can go into both.
That's where you're talking, yes.
That's what I'm saying.
You can do it, and you don't have to do it, you don't have to be hard on yourself. 2 goes into both of these, right? So if I cancel, how many times does 2 go into 210?
Oh, 105.
How many times does 2 go into 756?
It's 323.
You're close.
324.
How many times is the 8? What did you say?
328.
Not quite. You're almost there. It's 378. Now, all right, so this is what I have. I have 105 over 378. Now watch what I'm gonna do. Do you remember the trick I told you about in the first class? If I add up the digits, 1 plus 0 plus 5 is how much? 6. 3 goes into 6, so 3 goes into 105. Here's that trick. Now, let's add these numbers up. 3 plus 7 is what? 10 plus 8, 18. 18, does 3 go into that?
Yeah.
So 3 goes into this number as well. So I'm gonna cancel 3 out. 3 goes into 105 35 times. 3 goes into 378, 100, let's see. 24, yeah, 124, very good. No, that's not correct. You should have ended at 9. 330,
9 is
189, is that 189?
No, it should be 120.
It's 370.
It's 126.
I'll be here. Oh, I was thinking dividing by 2. No, you're right. Okay, the 126, good. All right, we have to rewrite 135 over 35 over 126. Is it simplified? So I can go into it.
6, 7, 7.
7, let's see, 7 goes into 35 5 times. How many times are we going to 126? I think it's 18. You know, it's a similarity between the answers.
Yeah.
So,
Now, you tell me, is that easier or is this?
Wait.
That's. So this, I gotta do that once a semester to convince everybody that I'm right. The next one we know is a positive number. Just whip out your calculator, I really don't care. It's gonna end up being 1.4. And the last one is, we already know it's gonna be negative, just whip out the calculator and tell me what you get for that one. You don't have to bother trying to do anything by hand. For this one, I end up with 34.77. And in fact, on these multiplication problems, you could have written all of them on your calculator just the same way you see it. You could have written, go on your calculator, write 11 exactly the way you see it on your calculator. Type it in exactly that way with parentheses and everything. You have to be in yeah, most calculators don't have parentheses unless you're in scientific mode, but I could be wrong. So if I type exactly the way it looks in the book. See problem. But it is. Any questions about this?
Yeah, this annoys me some, but I'm gonna have to do it. Let's go and do these. The negatives are annoying because what they do to the students, you try, I think what it is students try so hard to memorize everything, right? Instead of it feeling like it comes naturally to you, they'll try to memorize all the rules. So let's take a look at these two questions that we have, both similar, you can see that. What do you think the answer to number 21 is? Positive 36 or negative 36? Positive. What do you think number 22 is going to be? And the whole game here is that you're going to be second guessing yourself. So we need to address this ugly little business right now. And so, I mean, you'll get reminded over and over the whole semester, but let's take care of this ugly business right now. If you look at the first one, it's easy to see. The -6 is in parentheses, means that the author wants you to think of it as this way. -6 times -6. What's a negative times a negative? Positive. Let's say it's positive. Type it into your calculator exactly that way and see what it does. And you'll see it will give you positive 36, but you need to include the parentheses. How to talk about this next one? And how to explain to you the difference. What the author means by this. I'm not exactly sure what to do here to say how to say it, but you know that when the minus sign is on the PEMDAS collection of rules, right? So when you minus something, subtraction is lower than exponent, right? Yeah. Well, with that case, negatives are written subtraction. If you buy that, negative releases subtraction, then you can see which of this part should I do first? Should I do the minus part or should I do the exponent? Exponent. The exponent. What is 6 to the second power? 36. Then you didn't touch the minus, did you? You just did the order of operations. You understand?
So it is negative 36.
Absolutely.
Okay. I was thinking like maybe you just think of it as a -1, so then you do the PEMDAS, so you do this exponent and then
You
negative.
can't do that. I used to try, look, this has provided me with no end to astonishment and what students will take away from it. So you can, if you want to think of it as -1 times 6 to the second power, you can certainly do that. But if you're conscious enough to do that, you probably wouldn't make the mistake in the first place. Do you know what I'm saying? You would, if you're conscious enough to do something like that, you know this material. So there's the evidence we had to get out of the way. It's going to be a bugaboo for a while, but you'll get over it eventually.
I did not mean to click that thing. Did not want that. Division works exactly the same as multiplication. Look up at the screen. What would you think the answer to number 33 would be? Positive or negative? Positive. Number 34. What would you think that answer would be? Negative, and in fact it is. So division works identical to multiplication. Okay? So we know the first one to be positive. Do you guys happen to know what 50 divided by 5 is? Positive 10. And the next one we know to be negative. Any of you happen to know 84 divided by 12? 8, right? 6. 12. Oh, my God. You get one more guess. You said 6, you said 8, you get one more guess. 7.
In the ballpark.
Yeah, you were in the ballpark, that's for sure. Yeah, it works the same as multiplication does, so I don't think, I'm not gonna write up separate rules for it. I think you can handle it. I just want to make sure that I've done every topic that's in this section, and I think so. These are annoying though, the zeros. Let me grab these two things.
Not possible.
It is possible, but I'm gonna need, I'll make up something to explain. So let me grab these two. There's just, like I said, there's a couple of topics I gotta make sure I include everything so that you're prepared for your homework. All right, number 40, what kind of an answer is that going to be? What kind of an answer is it going to be? Negative, you got a positive number divided by a negative number. Fraction is a number, so keep that in mind. You have a positive divided by a negative, so it's going to be negative. Now, you might remember when you got fractions that you do this, a divided by b divided by c over d. Do you remember how this rule works? It works like this, a over b times b over c. You got it. You take the reciprocal of the second one. You flip the second fraction. Now, if you look, what's my a over b in this problem that I had the first one? What's the a over b? What's the a?
It's 21.
Right. You need, she just threw it in there. Didn't even need to do it like this. See this? So this way I have two fractions. Now, we already know it's going to be negative, so I can forget about the negative the rest of the way. Here's what I'm going to have. 20 over 1 times 7 over 15.
Or 5 to 15.
That's right. On 5, right, 5 can go on both the 15 and the 20. So I'll cancel out a 5. 5 goes into 15 3 times, and 5 goes into 20 4 times. Now finish it off with me. What's going to be the answer? Don't forget that guy. Negative.
Negative.
Oh,
Go ahead. I advise you, when you're doing a problem on a test, if you know the answer is going to be negative, go to the answer box and put a negative in there immediately. It's the most painful thing to get points taken off for, something like that. Now, this next one is controversial. You were saying is undefined, no, it's not. In fact, do it on your calculator and tell me what it gives you. Do 0 divided by 7 on it. You don't need to sign the calculator for that. Do 0.
So is it when zeros on top or the bottom?
This is the bad one here. Try that on your calculator. 7 first, that's undefined. So notice the 0 on top, it's fine, the 0 on the bottom, no good. What do you think this one's gonna be then?
0. No, it's undefined.
Undefined.
Well, that's about it. Makes sense.
Look, you don't wanna know the explanations for why these are this way. It's one of those things, I have to come up with. I have to come up with these, see, the thing is, if it had a value, you try to say, well, if it had a value, then I can add it to other fractions. And something gets messed up when you try to get common denominators and things like that. All right, so keep that in mind, this is a rule that you want to keep on, you cannot divide by 0 no matter what's on the top, you understand? 0 can't be on the bottom no matter what's on the top. You could try 0 over 0 on your calculator, you can see a little error will come up. Let's grab some, or, ooh, look at these things. My. Let's grab this number 52. I just cannot possibly ignore that one. Now, do you want to take a few minutes to try it, see if you can do it, or do you want me to just jump right into it?
Find it out.
Go ahead and work it. I mean, yeah, take a few minutes to work it, and then I'll go ahead and do it. You know, I'm going to challenge myself and do it in my head. Got it?
The exponent first.
No, there's parentheses before exponents here.
You do the brackets first.
That's right. Inside of the brackets first, in fact. You got one? Got an answer?
-9 plus 30.
All right, let's take a look. This class doesn't last long enough for us to ruminate very long on problems, so can't give you a lot of time, but there's no sense, and if I look and see that you're not gonna get it anyways, what's the point? So come up here, let's discuss, what should we do first in the problem? That's always what you should be asking yourself, what do I do next? What do I do next? So let's start. Go under our parentheses. Do we have parentheses?
Yeah.
Okay, so we're gonna use P first. Which P's are gonna be important?
And negative somewhere.
These don't count really as parentheses. Did I tell you? -3 and 4. They don't count as parentheses because all they're doing is putting a number, a holding place for a number in these cases. But over here, it's not the case. The thing that you want to do first is the -9 plus 30. What's that equal?
Negative 21.
Positive 21. I'm going to drop the parentheses now. You understand? This allows me to continue with the rest of the orders of operation. All I do simply is copy down the rest of it, and I just do the one thing at a time. That should be regular form. Okay, what should I do next?
21 divided by 7.
21 divided by 7, that equals
3.
3. What's between 5 and the bracket?
Multiplication.
Right. So I just did this part here.
So then -2 to the 5th.
So, right, because those two, like the -3 and the +4 are not considered parentheses. Those aren't considered parentheses. In fact, I made up a word that I call full parentheses for when they appear, but they don't have a function. So there's nothing to do inside them, is what I'm saying. We would do the exponent next. What would you get then? For that next, what's 2 to the 5th?
-32.
So we get a -32, right? We just talked about doing the exponent first. Copy the rest of it down. This way you can find your error that you made rather easily because I'm doing just one thing at a time. And notice the problem is getting smaller as I go, for obvious reasons. Essentially, if you want to think of it in one way or another, I'm simplifying the problem. That's all I'm doing. What do you think would happen next?
You do -12, the -3 times 4, and then do the
Right.
5 times 3.
Right, there you go. So what we're gonna have then is we're gonna have -32 minus -3 times 4 is -12. Now, what do you think happens when you minus a negative number of 5? What do you think happens when you have a negative, when you minus a negative? Bad. All right, exactly right. Because minus subtraction, you move to the left. Well, if you take a negative something, you move to the left. Okay? Here, so we can look at this as like going on the other side of 0, but then this negative brings us back to this side of 0. So here's what happens then. This is another thing that you need to take care of. This is a big one. Here, this is big. So we just use something like, if I have the negative of a number, it's just the number itself. You guys with me? Now go from left to right. -32 plus 12, what's that gonna end up being?
-20.
-20. You getting the idea? See, basically, we know it's gonna be negative because that -32 is the dominant number, right? So -32 plus 12 will be -20, just as you said. It's negative because the -32 is dominant. How did you get 20? What did you do to arrive at the number 20? Correct.
Yeah.
32 minus 12. So first, you make note of the sign. Then you add or subtract as needed. And I'm ready to finish it off now. What's my final answer going to be?
-5.
-5 indeed. Questions? No?
All right, I popped into 1.7. We do have 2 sections, actually. I'll do whatever I can in there. This guy, I think here pops me to the next section. There it is. Indeed, indeed, indeed.
I'll do the bunch that I can here for you. We'll see how the homework goes if you have questions, which is on Thursday. This is when another fundamental topic that you reach when you're dealing with math is something that's called like terms. Have you heard that phrase before?
Yeah.
This is something, this tells you when you can combine things and when you can't combine things. So in the heart of this is the distributive property, which is, let me see, how do I want to do it? You guys know what this is called? Distribution. Distributive property, right? Distribution, whatever you call it, I don't know there. Just so you know, that's name property. So you see it works on the other side too. If I like add a B plus C times an A, I could multiply this way as well. So I have B times A, C times A as well. And of course, with commutativity, these are all the same answers anyways. So we want to look at what's called like terms. So how exactly does that work? Let's do, I'll make it easy, so as an example. Here's what you might encounter. 7x plus 12x. Now, in math class, we typically use an x to represent a number that we don't know the value of. Right, an unknown quantity, if you will. Now, according to the distributive property, this version of it, the second version of it, this is equal to 7 plus 12 times x. Would you agree that's the second part of the distributive property that I just used there? Now, evaluate. What's 7 plus 12? 19. 7 plus 12. Oh, 19x. What it does is, this is the version, this is like terms. I have, basically, it's really easy to, if you think of it this way. I have 7 things plus 12 things. How many things do I have? 19 things. That's all the distributive property is. These are considered like terms because I can combine them using the distributive property. However, what do you think happens when you try to do this?
Are they separate now?
I can combine them. They're not like terms. But up here, they're like terms. So who is responsible for the for like terms? The distributive property. That has always been the reason why you could combine like terms. Questions? Let me grab an example on this. You'll see a lot of the stuff that we'll be doing, let's say simplify. Let me see if that's what this says. Well, list the terms and their coefficients. Oh, okay, this is not. Well, let's go ahead and I'm going to find something that actually has like terms. This book is way too many problems, man. I'll tell you what. All right. Well, I just answered this question right here. And these, here goes, do this. Might as well make use of it. Are these like terms? 3/4 n and 8n, would you say they're like terms?
Yeah.
They are. They have the same kind of n attached to both of them. So you know though that they're like terms when you combine them. So if I take my 3/4, if I take my 3/4 n and I add it to the 8n, hey, you see what they forgot to do?
I put the one.
They forgot to hit Control I to make it back to regular one.
Oh, yes.
He didn't type Control I. Okay, so anyways, we did the distributor property says that I can peel off the numbers. And this is how you know that they're like terms, because I was able to take the same n out of both of them. Do we want to talk about how to add those numbers or not? Should we approach that ugly thing right now? Let's do it. Well, not the section for it. The section for it is down the road a couple of sections, but nonetheless, it doesn't hurt, I don't think. 3/4 plus 8. You might as well make it 8/1. Now, when you add fractions, they have to have the same denominator. In a common denominator, you've heard that phrase, right?
So 8 times 4.
Right, exactly. I can't take the 3/4, I can't, I mean, I can make it, I can unsimplify it, right? But that's not the one that I'm gonna be looking at and make a common denominator, because the other one's just 1 for the denominator. So the 8/1, I'm gonna look at it and I need to make that one into a 4.
32/4.
Right, so you can do 1 times 4 and 8 times 4. So we get 3/4 plus 32/4. Do you remember how you add fractions then?
Should we same denominator, different?
Same denominator.
Yeah, so 35/4.
Right, add the numerators. So this will end up being 35/4 times that. Now, some of you, I see this occasionally on the early parts, at least for it, some students will go through the effort of writing it as a mixed number. I wouldn't bother doing that. Just leave it like that. We'll deal with mixed numbers later, but you never have to change them to mixed numbers. This is perfectly fine as an answer. Will end with this one then. So this here is a perfect example of like terms. What I want you to do, now numbers are always like terms to numbers. Numbers and numbers are always like terms. Now, what you're allowed to do here is rearrange things. So can you tell me, I'm gonna start with this -3p. Looking across all these, can you tell me what other piece of it is like term to this?
The P.
The just plain p. In fact, that p is equal to 1p, isn't it? So I can do -3p plus 1p. Now, the next I'm going to come up to is that 6p squared. Do you see anywhere in the expression that something that's like with it? 3p squared. All right, so I've got the p's, I'm just cancel them out as I'm using them. Then last, I've got the numbers. -2 minus 5, -2 minus 5. Now let's finish it off. What's the -3p plus 1p going to equal?
-2p.
That's right. -2p. How about 6p squared plus 3p squared?
9p squared.
9p squared. And finally, -2 minus 5.
-7.
-7. -7, -7. There's our answer, circle 5. Try the homework. If I need to do more 1.7, I will. Give it a try. Try to do it before you come here on, Thursday, because this homework will be due a week from today. So you want to ask questions about it on Thursday. Okay, so at the end of this, I'll tell you how this operates, so you can see. I'm gonna stop the video, and then I'll get an email later that says upload it. So I'll get that. But at the end of class, what I do right now is I also copy these notes into Blackboard. If you look in Blackboard, there's a section called lessons. Old test, there's also lessons. These will be under lessons. Okay? All right, that's all I got.
Thank you.
Sure. Let me stop recording.